Don't forget that you must complete any uncompleted homeworks or tests that were given. If you haven't done them as yet, make sure to do them. If you can't access them because they're no longer available, you can send me an email and I will open it up for you. But you have I will, there were something like 20 Delta Math homeworks. There were 3 tests on Delta Math, and there were 2 tests on Blackboard, one being a test before the midterm, and there's a test now that has to be completed by this coming Monday, May 13th. You have until May 13th to complete that. I see some people have already done it. Make sure you have completed, because if you're missing work, it's going to count towards your mark. Your mark, 40% of your mark comes from classwork and homeworks, etc. And if you're missing if you're missing a midterm, if you're missing anything, you're going to be, it's going to affect your final grade. Grade does not just depend on the final exam. 40%, 35% of your grade is from the final exam, 25% is from your midterm, and 40% is the homeworks and classworks and class tests that you had. So make sure you have everything done. And I will probably be sending out emails to people who are missing work. If I see that you're missing anything, I will send you an email, but it's up to you really to check if you're missing anything. Okay, so let's look at example number 1. Where we want to expand this complicated expression into its individual logs. And the way we do that is, first of all, make sure that anything that's written in a radical form is rewritten as a exponent. When we're using logs, we do not write radicals. We change that. So this is going to be, we're just rewriting this, log base 6. Remember, the cube root of x can also be written as x to the 1/3 exponent. Any radical can be written as a fractional exponent, where the index is the denominator of the fraction. So this is really just rewriting what I had originally by changing this cube root of x to the 1/3. And then remember our rules for expanding logs, what we call the properties of logs. Logs or logarithms are basically exponents, and the rules that apply to logarithms are the rules that apply to exponents. So when we're multiplying numbers, we know we add the exponents, so that when we're multiplying numbers, we add the logs. And when we're dividing, we subtract. And when we have exponents, those exponents we multiply by those exponents. So when I want to expand an expression in terms of logs, the first thing I do is I look for any multiplication and division. And we do this when we look at a fraction. Anything that's in the numerator is considered as being multiplied, anything in the denominator is looked at as if it's being divided. It's considered dividing because even though we're, let's say, multiplying the z squared times the y, we're dividing anything in the denominator is really a divisor. So when I'm going to write this in terms of logs, it's going to be the log base 6 of x to the 1/3. That's going to be positive, minus the log base 6. Don't forget you have to write this log base 6 in front of each term of the z squared, minus the log base 6 of y. Notice I don't put a plus between them because even though these both are being used to divide by, I then go back and take any exponent and make it into a coefficient. So this will become 1/3 log base 6 of x. Here's an exponent, so that's going to become a coefficient minus 2 log base 6 of z. There's no coefficient here, exponent here, so we just write it minus log base 6 of y. And that's how you would write this expression as in its expanded version in terms of the individual logs. 1/3 log base 6 of x, 1 minus 2 log base 6 of z, minus log base 6 of y. Reggie, do you see that you'd have to put a 1/3 instead of that cube root if you really want to expand it? Because that cube root has to be written as an exponent. Once it's an exponent, it goes in front. And I see, Kava, you put the 3 on the bottom. Yes, you could write this either as a 1/3 or could put the whole thing over 3. That would be acceptable as well. Okay. The next question was, find the log base 4 of 64. Now, if we want to find the log, the basic way of figuring out log questions is to go from the log format to the exponential format. And I have on the board the rule. If you have log base b of a equal to c, in exponential form, it means the base, the b, to the exponent c. The log is the exponent, so it's b to the c equals a. Now, in order to write this thing in exponential form, I need this to be equal to something. I don't know what it's equal to, so I'll call it x. And then I can switch it from the log format to the exponential format. The base again here is 4. The exponent is this number on the other side of the equal sign. So it's 4 to the x equals the 64, which is a number that's right next to the word log. We switched this from the log format to the exponential format. And really, this is just an exponential equation that we have to solve. And we try and figure out 4 to what exponent will give us 64. So let's do it. 4 times 4 gives me 16. 16 times 4 gives me 64. In other words, if I multiply 4 3 times, I'll get to 64. So it must mean that my log is equal to the 3. The exponent is 3. So that's how, and for sure these type of questions are going to come up on the final exam. Okay, let's see if we can do some more examples. I'm going to give you a couple more examples to work with on logs. And while you're doing them, I'm going to take attendance. Okay, see if you can solve this equation. Log base 4 of x plus 1 plus log base 4 of x minus 5 equals 2. See if you can solve this log equation while I am taking attendance. Maury Albury, Chelsea, Ariana. Ariana here? Adina.
I'm here.
Hi, how are you? Lachey.
I'm here.
Hi.
Hey.
Kava, I know you're here because I spoke to you before.
I'm here.
Yeah, hi. Terrence. Oh, Ariana, right. I've got you now. Is Terrence Cruz here? Karide. Kizia?
Here.
Okay, hi, Kizia.
Hello.
Faith. Ethan?
Here.
Hi. Isabella? Hi. Serenity?
Here.
Hi.
Hi.
Reggie?
Here.
Hi.
Hi.
Samia? Brandon? Michaela?
Here.
Hi.
Here.
Seraphine? Marissa? Renee?
Here.
Hi. Sky, I know you're here. Jaden? Kennedy. Alicia. Alicia here. Natalia.
Here.
Hi. Michael. Okay, Maury, I see you're here. Michael, hi, got you. Cassidy Tucker. Hi. Megan. Megan. Kalia. Lauren.
Here.
Hi, Lauren.
Hi.
And Kayla Zachary. I'm missing 3 people, so let me see if I can figure this out. Oh, Karide, okay, I'm glad you're here, okay. You're gonna see me on Thursday, Adina. Also, you can join the SI classes. I think today it's from 12 to 2, so after this class, there is a little bit of time if you want to go to join the SI. Okay, let's see if we can do this example. All right, we've said that basically if we want to solve logarithmic equations, we want to change them from the log form into the exponential form. The only problem here is that we have more than one log on a side. So in order to be able to first transfer it into log format, what we're going to have to do is we're going to have to get this, contract this back to a single log. Before, the problem involved expanding it, going from one log into multiple logs. Here we're doing just the opposite. We have two logs. We really want to get it back to a single log. And we know when we're adding logs, what we're really doing to the numbers is multiplying. Because again, the logs are exponents, and when we add exponents, we know we're really multiplying. So I could rewrite this as the log base 4 of x plus 1 times x minus 5 equaling 2. I was adding the logs. That means I'm multiplying the two numbers, the two algebraic expressions. And of course, now that I have a single log over here equaling to a number, I can go from the log format to the exponential format. There's my basic rule. My base is the subscript, which in this case is 4. Don't forget, if no base is written in, it's not that the base was forgotten. It means that we're dealing with what's called common logarithms, and the base is 10. So if you just see the word log and there's no number here, it's really like there's an invisible 10 over here. In this case, there is a number showing, and it's 4. That means our base is 4. The number on the other side of the equation is the exponent. So this means 4 to the 2 equals whatever's next to the word log, which is the x plus 1 times the x minus 5. So we've gone from a log equation to a regular algebra equation. And in order to solve this, we have to do 4 squared, which is 16. And over here, I'm going to use FOIL. I have to open this up so I can combine all the like terms. So this is going to be an x squared. Outer is negative 5x. Inner is plus 1x. And last is 1 times negative 5 is negative 5. It's obviously a quadratic equation because we have an x squared, so I'm going to have to get it equal to 0. So I'm going to have to subtract 16 from both sides. This will give me 0 over here. Combine the like terms, I have an x squared, a negative 5x and a plus 1x gives me a negative 4x, and a negative 5 and a negative 16 gives me negative 21. So I have this quadratic equation that I have to solve. So how do we go about doing that? Well, we know using the AC method, my AC is 1 times negative 21. So that's negative 21. My B is negative 4. So I'm looking for two numbers that when I multiply them are going to give me negative 21. And when I combine them or add them, I'm going to get negative 4. I think it should be obvious that it should be a negative 7 and a positive 3. So this will give me x squared minus 7x plus 3x minus 21. No, but notice all I've done is I've broken this negative 4x into negative 7x and plus 3x. And now I'm going to group. In my first group, I'm factoring out an x, and I get x times x minus 7. And in my second group, I have a positive 3 as my common factor, so that's also giving me x minus 7. So this factors to x minus 7 and x plus 3. And of course, I then set each one of these individually equal to 0. So x minus 7 equals 0 will give me x equal to 7, and x plus 3 equals to 0 will give me x equal to negative 3. And I'm not finished until I check to see that both answers are good answers. Do they both give us proper answers, or is one of them what we call a will one of them not give us a good solution? Why could it not be a good solution? Because when we're doing logs, the logs always have to be positive. Now, if I pick x to be 7, this will be a 7 plus 1, which is 8, which is a positive number. And this will be 7 minus 5, which is 2, which is a positive number. So x equal to 7 is good. But when I try to use x equal to negative 3, even right away, in my first parentheses, negative 3 plus 1 is negative 2. I can't do the log of a negative number, so I have to throw out this, what we call extraneous root, and the only correct answer is x equal to 7. So even after we've done all the work, if we don't check, if you wrote down that both answers are negative 3 and 7, you would get the question wrong. I guarantee you there's going to be a question like this on the final. And one of the things it's going to have is probably going to have one answer being correct and one not. And one of the choices will give you that answer. If the answer would be 7 and negative 3, and you pick that answer, you would get the question wrong. So be very careful about doing the check in this case.
I have a question. In this
Yeah,
case,
sure.
so in this case, like if it were to be this question right here, right? Like, would you have to like pick 7 instead of 7 and negative 3, right?
Right. In other words, if one choice,
Like if this were to be one of the questions, let's say. So you will have to pick 7 instead of 7 and negative 3.
right, absolutely. If you pick the choice 7 and negative 3, let's say here are the choices. It's a multiple choice, and here choice A is negative 3 and 7. Choice B is negative 3. Choice C, I'm just making this up, is 7, and choice D is nothing. Remember the symbol nothing. And you pick this choice, you would get that question wrong. Because negative 3 is not, this is the only, to say that something's an extraneous root means it doesn't work. It's not good. You can't use it. Okay? So that was, thanks for bringing that up, making it very clear that we must pick only the answer that has 7, not 7 and negative 3. Okay, Terrence, I'll mark you here now. Okay, let's just do a couple of these. I think we're pretty okay on the log equations. Let's see if we can do an example with an exponential equation. What if I gave you this? Okay, this. 5 to the 12 minus 2x equals 125. This is an exponential equation. See if you can solve this exponential equation. You see, we have somebody has an answer. Let's see if anybody else comes up. I'll give you another couple of minutes. Looks like the right answer, Ariana. Okay, let's do it together now. I see a couple of people have finished. Looks like they know how to do it, but let's review it. This, when we have exponential equations, and we'll know it's an exponential equation because the variable, what we're looking for, the unknown, is in that exponent. We're going to try and get both sides written in terms of the same base. Now, this is written in base 5. This says 5 to this exponent. We're going to try and write this side in terms of 5 to an exponent as well. And if I do the exponents of 5, 5 times 5 is 25, and 25 times 5 is 125. So that means if I multiply 5 3 times, I'll get to 125. So I could rewrite this 125 as 5 to the third power. And once we have the same bases, then we can just set the exponents equal to each other. So 12 minus 2x will equal the 3. And now I'll just solve this simpler equation because I don't have, if the bases are the same, I just have to work with the exponents. Well, I'll bring this 12 to the other side. So that'll give me negative 2x equals 3 minus 12, which is negative 9. And I'll divide both sides by negative 2. And of course, -9 divided by -2 is 9/2. And it's good, it makes sense to leave your answer as a fraction rather than going to decimal forms. And yes, this is the correct answer. I see a couple of people came up with that same answer. Great. Okay, so let's do another exponential equation, one that's a little bit different. What if I had something like this? Eight to the x is equal to 55. This is also an exponential equation. And we start off doing it the same way we did before. We try and get both sides to be in terms of the same base. Now, the base I'm using here is 8. So let's see what I can do with 55. So 8 to the first power is 8. And 8 times 8, 8 squared is 64. I passed right over 55. 8 to the 1 was too small, it was just 8. 8 squared was 64, and it was too big. It very often happens that you cannot get both sides to be written in terms of the same base. But there is a way of solving this using our calculators. If you recall, what we did is we put the word log in front of both of these expressions. So we get log of 8 to the x equaling log of 55. And if you notice, I didn't put a log with any base in it. It's not that I forgot the base. I'm going to actually be doing log base 10. And the reason I want to do log base 10 common logs is because I want to be able to use my calculator to solve this. So if I want to go to solve an exponential equation, I can do it using base 10 logs. Now, the reason I want to use logs is because in logs, the exponent becomes the coefficient. We did that when we did our expansion. If we expanded this would become x log 8 equaling log 55. And then if I want to find out what x is, I just divide out the log 8. Remember, I divided out because this is x times log 8, so I have to divide by the log 8. And I'm in my calculator. That's what the beauty of this is. If I used a different base, I wouldn't necessarily be able to use my calculator. But here I can use the calculator. I press my log button. Remember, the log button means log base 10. I put in the 55. Making sure to close that parentheses. I then do divide, because I want to do the bottom of the fraction. Again, I press my log button, and I put in the 8, and then I press equal. It will not come out to be an exact number. So let's say we didn't take what we wanted to. Let's say we wanted it to the nearest hundredth. That means 2 decimal places. So on my calculator, I'm doing log 55, closing that parentheses, and then I'm dividing log 8. And I get 1.927119905. Probably doesn't even end there because it just stops there because there is no more room on the calculator. But I want it to the nearest hundredth. That's 2 decimal places. I see the number after the second decimal place is 2, is a 7. So my answer would be 1.93 to the nearest hundredth. And notice, of course, it's less than 2 because we know when we did 8 to the 2, it would give us 64. So this would have to be somewhat less than 2. And that's how we can solve an exponential equation, even if we can't get both sides in terms of the same base, by just doing logs, common logs, logs base 10. I think that pretty much takes care of what we have to be able to do when we want to work with logs. We have to know how to expand logs. We know how to solve exponential equations. We have to be able to change from log format to exponential format, and we have to solve log equations. And we reviewed it. There will be 4 or 5 questions on your final that have to do with either exponential equations or logs. So it's very important that you know how to do these type of questions. Again, your final exam will consist of 30 questions. The practice final exam has 40, but the actual final has only 30. That's to make sure you have enough time. So make sure you know how to do these log equations. So what I'd like to do now is do a quick review of some trigonometry, of the types of questions you need to know for trigonometry. I'm sort of going backwards in the types of examples we're doing. I will review midterm examples on Thursday. Remember, Thursday is our last class. If you have any particular topic that you would like me to review, make sure to send me an email to let me know. What if I gave you a problem that looks like this? Use a right triangle with your right angle at C. And suppose I tell you that side A is 17 and side C is 24. And I want you to find side B. If it doesn't come out even, put it in simplest radical form. I'm going to give you a couple minutes for that. Okay, let's see if we can do this together. First of all, let me label my sides. Small a is opposite the capital A, so this will be my small a. The C is opposite the right angle. In other words, this is our hypotenuse, and this is B. And we were told that A is 17 and C was 24. And the way we find the third side of a right triangle is by using the Pythagorean theorem. The A squared plus B squared has to equal C squared. So sticking in the numbers, 17 squared plus B squared equals 24 squared. I'm going to use my calculator to figure this out. 17 squared is 289. And B squared, we don't know, and 24 squared is 576. So I'm gonna have to subtract 289 from both sides, which gives me B squared equals 287. And that means that B is the square root of 287. Now, I don't think there's any way that I can simplify it. I think the only thing that divides evenly into 287 is 7. That's not a perfect square. So my answer in radical form would be 287. That would be the answer that we would find. Okay. Okay, so let's do another example. So there, and again, there'll definitely be a question like this on the final finding using the Pythagorean theorem. There always is. What about trigonometry? Well, what if I gave you a question like this? We give you a picture of a triangle. Again, a right triangle. Let's call this angle theta. Let's say this side is 5 and this is 22. And I want you to find secant theta. And I want you to find it in simplest radical form. If it doesn't come out evenly, then do it in the simplest radical form. Okay, I'm going to give you a couple minutes to try it, and then we'll do it together. Okay, I think we should try it together now. What do we have to remember? First thing we have to remember is our SOHCAHTOA. And make sure you know how to spell it right. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Those tell you about the three primary trigonometric functions, the sine, the cosine, and the tangent. We also have three, I'll call them secondary. They're not on their calculator, but you still have to know what they stand for. There's something called the cosecant. It's abbreviated CSC. It's the reciprocal of the sine. There's the secant, SEC, which is the reciprocal of the cosine. And there's the cotangent, COT, which is the reciprocal of the tangent. And if you remember the way I told you to remember it, if this starts with a C, so its partner starts with S. So cosecant has to partner with sine, and secant partners with cosine. Obviously, tangent and cotangent going together makes sense. All right, so if we want to find the secant of theta, what we have to do is find the cosine of theta and then take its reciprocal, which means just turn it upside down. Now, the problem with trying to find the cosecant, the cosine here in this problem is that I don't have enough information. The cosine is the adjacent over the hypotenuse. And what I have here, this is my opposite side, and this is my hypotenuse, and I don't have the adjacent. Let's call this B. So just like we did before, we're going to use a Pythagorean theorem to find the third side of the triangle. We'll do 5 squared plus B squared equals 22 squared. So this is 25 plus B squared. Okay, 22 squared is 484. So I'm going to have to subtract 25 from both sides. And that'll give me B squared equals 459, which means that the B is the square root of 459. Now, I noticed right away, because I see a 45 and a 9, that this is divisible by 9. This is the square root of 9 times the square root of 51, which gives me 3 radical 51. In other words, I asked for this in the simplest radical form. So I have to remember to try and break up my number so that one number is a perfect square. So this is my 3 radical 51. Now the cosine of theta is adjacent, which is 3 radical 51, over hypotenuse, which is 22. So cot, adjacent over hypotenuse. So the secant would have to be the 22 over 3 radical 51. The reciprocal of the cosine is the secant. If we would have been asked for cosine, we would have given 3 radical 51 over 22. The problem with this is that we have a radical on the bottom, so we have to rationalize the denominator by multiplying by the square root of 51 times the square root of 51, which gives me 22 radical 51 over, well, this is 3 times 51, because the square root of 51 times the square root of 51 is 51, which is 153. So my final answer in this case would be 22 radical 51 over 153. And this is quite a bit of work for just one problem. Usually they don't give such hard numbers. Remember, I just sort of pulled these numbers out of the hat, so they were a little bit more difficult, but you should be able to, from given any two sides of a triangle, you should be able to find the sine, the cosine, tangent of it, even if it's not the proper sides. Let's see if we can do just a couple of problems that have to do with conic sections. See if you remember this. What if I gave you this? By the way, don't forget, remember I posted this study guide for Math 136 on Blackboard. It has all the different formulas and all the different types of questions you might encounter. It's a very good study sheet to reviews all the different things that you may need to know for this course. So what if I gave you a question that looks like this? I have a circle whose equation is x squared plus y squared minus 4x plus 6y minus 12 equals 0. By the way, I told you it's the equation of the circle, but you should recognize right away it is the equation of the circle because you have an x squared plus a y squared term and no coefficients. They both have coefficients of 1. That always makes it a circle. I want you to find the center and radius of the circle. Give you a few minutes to try that. Okay, do you have the center, Ariane? It looks good to me. Let's see if we can do this together now. In order to find the center and radius of the circle, we have to put it in what's called the standard format. Yeah, that looks good, Reggie. The standard format will give us automatically the center and radius. So in order to do that, I first get all the x terms together. So I have x squared and negative 4x. And I leave myself a space because I'm going to have to do what's called completing the square. Then I put the y terms together. So I have a y squared and a 6y. And any other just plain numbers have to go on the other side. So this 12 I'm going to bring to the other side of the equation. And what I want to do is complete the square on the x's, which means add a number over here that'll make this into a trinomial that I can factor into a binomial squared. And the way we do it is we take the coefficient of the x term and divide it by 2. So negative 4 divided by 2 is negative 2. And I take that number and multiply it by itself. I square that number. Negative 2 times negative 2 is positive 4. And I add that 4 to both sides of the equation because I want to maintain my balance. This then, this x squared minus 4x plus 4 becomes x minus 2 squared. I've made this into a perfect square trinomial. I'm doing the same thing with the y's. I take half of the coefficient of the y term, which in this case is plus 3, and square it. I multiply it by itself. 3 times 3 is 9. And I put plus 9 here, which means I put plus 9 on the other side as well, maintaining my balance. This y squared plus 6y plus 9 now becomes y plus 3 squared. And now if I add up everything that's on the other side, plus 12 plus 4 is 16, plus 9 is 25. I now have this in standard format. And the center of the circle is these two numbers with their opposite signs. So this will become, for the x, a positive 2, and for the y, a negative 3. And the radius is the square root of this number. The square root of 25 is 5. So that's how you find the center and radius of the circle. Let's just do one more question. It has to do with conic sections. What if I gave you a parabola? What if I gave you a parabola? Here's my equation of my parabola. y equals x squared plus 4x plus 5. By the way, we would recognize it as a parabola because even though it has an x squared, it does not have a y squared. It only has the x squared. That makes it a parabola. And what if I asked you to find the vertex of this parabola? I got you, Felicia. I saw that you had been here. Okay, let's go over and let's do the vertex. Remember, the vertex is the place where the parabola, remember, it's that U shape. It's that bottom point at the bottom of the, this is our vertex. Or here, also sometimes called the turning point. And the way we find the vertex is we do x equals negative b over 2a to get the x value of the vertex. That looks good, Reggie. And to get the y value of the vertex, we then stick that number back into the equation. Now, in this case, my a is the number in front of the x squared is 1. The b is a positive 4. The c happens to be 5, but we don't need the c for this. So we're going to do x equals negative 4 over 2 times 1, which is negative 4 over 2, or negative 2. So the vertex is going to be negative 2 something. Remember, vertex is a point, so you need not just an x value, you need a y value as well. To find out what the y value is, we're going to stick this negative 2 into this original equation. So we'll do negative 2 squared plus 4 times negative 2 plus 5. Negative 2 squared is 4. 4 times negative 2 is minus 8 plus 5. So 4 minus 8 is negative 4 plus 5 gives me positive 1. So the y value for that negative 2 is 1, and my vertex is a point negative 2, 1. Okay, I think we're going to stop here. Again, if you have any questions or topics that you'd like me to review, just send me an email so that I'll be aware and do it on Thursday. Our last class this term is Thursday. Our final exam, I see it, I have it written down, is a week from today, Tuesday, December 14th. The test will be available starting at 9:30 until 2:30. If you can't, you must complete it within a 2-hour period. You can't start it after 12:30 because you won't have 2 hours. And if you start later, then you're just cutting yourself off. You're just giving yourself less time. I'm giving you more time, a little bit of extra time above what the is stated on the final exam schedule, because I know sometimes people run into problems with their internet and the internet cuts off on them. So my suggestion to you is to get started as early as possible. If you can't start it, if you have something else doing, obviously, if you have a conflict, you have to let me know. But you should try and start as close to 9:30 or 10 as you can. So if you do run into a problem, I can reset you. I will be available until 2:30. I'll be checking my emails constantly to see if anybody has a problem. I know this happens every term. Somebody has they're almost at the end of the test and the whole thing shuts down. Unfortunately, when the internet cuts out, it automatically submits your test. If you wanted to finish up your test, there's not going to be you're not going to be able to finish up the test. You can restart it. It's going to be, so try, and I hope you try to be someplace where your internet is stable. It makes the most sense. But if you run into trouble and you need to be restarted, I will be available next Tuesday. Again, if you have any missing homeworks or any missing tests, make sure they're done by the end of next week, because once I've made up my marks, I'm not changing it because you then hand in work late. 40% of your grade consists of homework and class tests. And there have been 3 tests on Delta Math, and there have been, we're up to the test number 2 on CUNY Blackboard. There is a test that is a prep for the final exam. That is for a mark as well. So you have, aside from the midterm and the final, there were a total of 5 tests in this class. All of that has to be completed by the time, I'm giving you a little bit of extra time. It really should be completed by the beginning, by Monday before the final exam. But if there's still some homework they have to complete, you'll have a couple of extra days. I will be looking through my records and checking to see if anything is missing and letting you know if I see that you're missing material. Again, if you have anything that you'd like me to review, just send me an email. There is SI sessions. You can try going to that as well. Have a good day, and I will see you on Thursday for our last class.
Oh, good afternoon, Professor.
Bye-bye.